But just kicking us off here, my name is Dan Mangum. I'm the cloud lead at Goliath, and I'll hand it off to Noah to introduce himself.
Thanks, Dan. Hi, everyone. I'm Noah Pendleton. I'm a firmware engineer at Memfault. Been at Memfault about 2 years now. I work with customers and partners like Kyle at NXP on integrating our product and building out new features, like cool new platforms, that sort of thing. My background is in embedded engineering. Been doing it about 12 years, and previously I worked at Fitbit, like the smartwatch manufacturer, and some other sort of like high reliability systems. So yeah, I'm pretty excited about device reliability. It's been chasing me my entire career.
Yeah. Thanks, Noah. So my name's Kyle Dando, and I'm with NXP. My main responsibility at NXP is the ecosystem, and that means working with partners like Goliath and Memfault, but also making sure that our software that we deliver to the customers is easy to use and provides all the value you guys as customers require. So before we jump into anything, I just want to tell Noah, I mean, it's been 2 years, like you said, that you and I started working a while ago about integrating Memfault and introducing it to more NXP customers. So I can't believe it's been 2 years, but here we are. And
Time
then
flies.
Dan, I know, it's been crazy. Lots has happened. And then Dan, we were talking about a year ago when Noah and I were talking to customers about what we had done. We kept bumping into you at shows and at customers where the Zephyr group and the Zephyr project, where all three of us are active members, and so we thought it made a lot of sense for the three of us to come together, NXP, Memfault, and Goliath, and show all of you, the customers, the benefit you can get. So I thank Memfault for putting this all together, pulling this together. But a large thanks to Goliath. I know you guys put a lot of effort in the last year pulling this together so we can show people what we're trying to solve. So why don't we jump into the agenda? Like I just said, we're going to show you, hopefully by the end of this webinar, what Goliath, Memfault, and NXP can provide you. It's the problem that hopefully most of you are trying to solve. And before we jump into that, we're going to just give you where we contribute to the solution so that when we get to the most important part of the webinar, you have some context. So I'll go through NXP's contribution. Likewise, Dan will go through what Goliath will provide, and Noah will talk about Memfault's contribution. But we really think that the demo and what that's going to show you is going to spur a lot of questions. So stick around for the demo. It's very interactive. It's a great example of the benefit that you could receive by integrating this solution into your own products. So with that, what a better way to start. I hope I generated some smiles in the audience. The connected cow. So I've been doing this quite a long time. I think I heard about the IoT back in 2007, maybe 2005. Long time ago. I think you guys were in high school, and but I was out in the working force. Why am I sharing the connected cow? I think it actually is a great representation of what we're trying to share today. The connected cow is an old industry. Cowboys used to be on the range and they'd have a branding iron, and that was updated to the plastic ear tag so that they could manage their herd. Now, with the Internet of Things, we're seeing the applications like this where they can actually provide more intelligence and do a better job of managing the cow. So they're tagging the cow. That introduces so much complexity into something as simple as a branding iron. And that is where I think at the end of this webinar, you're going to see the value of Memfault. You're going to see the value of Goliath, as well as obviously using the NXP microcontroller. Because we'll touch on this multiple times. It's about that remote connected device. What better representation than a cow wandering in a pasture? I don't think any of you, if you're into troubleshooting your products, want to go step around cow patties and be in a field trying to connect a USB cable to a cow, or worst case, a bull. So the remote ability to monitor and diagnose your products in the field, we'll touch on that. The second is the ability to diagnose your software rollouts. So when you guys are connecting to the cloud, you want to make sure that you're able to diagnose your products and see if your changes are impacting your product. Like Noah mentioned at Fitbit, when they're rolling out releases to products, is the battery life being degraded quicker? Are there more crashes? And so with Golioth's connectivity and Memfault's diagnostic capabilities, you're going to see that we can make these cows not only healthier, but we can make those cowboys spend less time, replacing batteries and ear tags, and more time singing by the campfire. So, all right, that was enough of my funny story. Now let's jump into where most of you are building products. Apologies for those that are actually building cow tags, but we see more applications, as I said, every day. I'm not going to touch on all of them, but you can see them all identified here. And this is where those same challenges occur. You have your product, you need to deploy it. Now your management is telling you that you need to, due to regulations or due to customer feedback, you need to, or competition, you need to connect it. You need to be able to see what your customers are doing with the products. You need to be able to respond to security issues. And so the connectivity is a key issue. More important, as I mentioned, all these devices are going to most likely have an upgrade in the future. How's that upgrade impacting your fleet of devices? How are you able to manage that? And that's what Golioth and Memfault are going to provide you in this webinar. What NXP provides, you can see in the middle of this chart, we call it the edge processing continuum of products, of processing. And what NXP provides as a benefit is that you can come to one reliable supplier and get the latest and greatest in processing capabilities. And I'll share a couple highlights about that when I talk a little bit about NXP. But this is the problem we're solving. We're trying to connect all these devices to the IoT. We're challenged by the remote nature, battery life, getting diagnostics, seeing how it's being impacted, and preserving the processing power of those remote devices. So let's see how we solve it individually. So why don't we first I'll give a quick update on that edge processing continuum from NXP on the next slide. But before I do that, I'd love to get your input. We have it's getting to be a large audience here. Can you take the time and fill out this poll? What's your experience with NXP? Have you designed with NXP in the past? Give you a couple minutes or seconds maybe to answer the poll. All right. Well, while you guys are answering that poll, this is really the processing continuum that I talked about, and it's really providing the customers devices not only at the low end, smaller devices, Cortex-M core like devices, but offering this crossover MCU that's been so popular over the last 10 years, where you're bridging the gap between the low-end Cortex-M devices and those high Cortex-A processing demands. I'll share some new devices that are in the crossover and in the Cortex-M domain that help with your products. So why don't you show everybody what we're excited to share. We announced the MCX last year. I'm excited that in January, and in just over a month, we're going to be providing access to the silicon and the development boards, and really allowing the customers to start developing with the MCX. For our connected edge, the benefit is that it has all those neural network devices and coprocessors. Similarly, we're releasing the 1180 device, and the 1180 device is that crossover device. As you can see there, it goes up to 800 megahertz, so a lot more processing power. And another thing it has in this is the integrated gigabit switch. So again, on those edge devices that could have lots of sensors and lots of aggregated data, the 1180 is going to have all that high-end horsepower, whereas the MCX device is going to allow you to maybe very focused, maybe AI, ML type applications, and connect up to the cloud with that information. Last thing that I want to cover is what my direct responsibility is on, which is the ecosystem like I talked about. So I deliver the SDK, all the middleware that NXP provides, but I work a lot with our tool vendors. So NXP wants you to use the tool that you guys prefer. So we support MDK from ARM, we support IR Workbench, and with NXP, we provide both an Eclipse and a VS Code-based IDE. And in delivery, we're working on improving the GitHub integration, and we're introducing Open Synthesis Pack support to help you guys develop your projects in an easier manner, get access to the software quicker, and be able to manage your projects appropriately. So that's it with the NXP overview. I want to jump into the Golioth guys. I'm excited to hear what the rest of you guys have to talk about.
Awesome. Thanks, Kyle. That was a great overview and introduction. And this was my first time learning about the connected cow, so I was pleased to get to have that experience along with all the attendees. So like I said, my name is Dan. I'm the cloud lead at Golioth, and I'm going to talk a little bit about how Golioth works and what our value proposition is. But before we do that, I'm going to pull up our second poll of the day, which will launch for you here shortly. And really just what we're trying to get an understanding of is what services you currently use today to get data from your devices to the internet. So there's a couple options here, as well as kind of self-hosted if you're running your own stack on that front. So looking forward to hearing your feedback and responses there. So the Golioth team is comprised of folks who have spent many years in the IoT and connected devices space. And developing connected products is full of complexity, as you need expertise in hardware, firmware, cloud services, and application development. So really up and down the stack. Through our experiences in building these types of products, we've become keenly aware of the pain points in each one of those domains. So whether you're managing sourcing hardware components during a shortage or building distributed scalable application backends, we know what aspects of product development are differentiators and what parts are just plain overhead. The majority of that overhead exists between the actual physical device and the end user interface of your product. And the architectural decisions you make in that so-called messy middle can impact your ability to deliver a seamless end-to-end experience. So with that in mind, we built the Golioth platform to make connecting those devices, especially ones in constrained environments, simple, secure, and efficient. And along the way, we've incorporated best practices from embedded, cloud, and application development, meaning that everything from pulling new drivers into your firmware to integrating device management with infrastructure as code and CI/CD systems is considered by the platform. And because those connected products require expertise in multiple domains, we've also ensured that Golioth is a place where your whole team can collaborate. Firmware engineers can roll out an OTA update, while backend developers add new destinations for streaming device data without the need for offline coordination. Everyone is empowered to do their best work, and organizations are able to build products that previously would not have been possible. In order to offer this experience to a wide variety of customers, each with their own architectural intricacies, it's been vital for us to partner and integrate with vendors and projects in the hardware, firmware, and software realms, two of which we're going to see today. Whether ensuring that customers are able to leverage the best hardware for the use case, such as the NXP MX crossover MCUs, which is what we're going to be using in our demo here in a few minutes in this webinar, or providing access to cloud services for data processing, observability, and more, Golioth allows you to optimize your architecture as well as allow for it to evolve over time. This emphasis on integration is a pretty key part of the technical architecture of the Golioth platform. Our device management services, such as logs, OTA, settings, and more, ensure you have everything you need to manage large fleets of devices. For all the data that needs to flow between the devices in the cloud, we enable you to choose the best tools for the job. And those tools don't necessarily have to be built with constrained devices in mind. Rather, Golioth handles providing a secure and efficient connection between the devices in the cloud using the constrained application protocol over DTLS, then allows for transformation and delivery of data to any destination that you like. Many of our customers who run their own backend services as part of developing a connected product find this to be a force multiplier in their organization, as the firmware engineers can count on a reliable transport that isn't going to negatively impact the performance of their devices, and the cloud engineers can develop services rapidly using technology that they're already familiar with. Some of the services we integrate with, such as Memfault, are focused on devices and solve critical issues related to observability. Memfault is unopinionated about how you get data to the platform, as long as you can eventually deliver the payload via their HTTP API. This allows customers to easily integrate the service at any point in the product development lifecycle, but also means that unless their devices are already using HTTP, they'll need to provide some intermediary to get the data from the devices to the cloud. Golioth removes this burden by allowing customers to use the same secure and efficient connection that they're already leveraging for device management features to also talk to services like Memfault or any other platform over whatever protocol that they choose to support. The result of this is smaller firmware images, less network overhead, and a more seamless journey from prototyping to production. Our customers consistently report that they have been able to move faster with higher confidence, driving down both technical and organizational costs. And with that, I'm going to go ahead and hand it off to Noah to tell you more about the data that Memfault SDK can deliver over Golioth's transport and all of the features of the Memfault platform that help you understand exactly what that data means.
Awesome. Thanks a ton, Dan. Yeah, so my name is Noah Pendleton. I'm a firmware engineer here at Memfault. I'm going to talk about the Memfault platform and like what Golioth enables us to like expose to you via like their reliable transport. So this title for my section, okay, go back down, sorry. More about Memfault. It's not a typo. It's referring to Moore's law, which is, that computing sort of paradigm where we say like transistor count and like computational power doubles approximately every 2 years. That may no longer like quite be holding, but when we think about IoT devices, it seems like the complexity or like the sophistication, the feature set, all these things that IoT devices require is, seems like it's exponentially increasing. And in order to manage that, we need like simple, like easy to use tools that unlock a lot of power of these devices. And that brings us to our next audience poll, which is which properties are most important to your device? Check all that apply, and whether that's battery, connectivity, performance, crashiness, or other. While those answers are trickling in, I'm going to talk a little bit about like the history behind Memfault and the background of what our platform provides, as well as like some detailed features. So Memfault, the platform, came out of our experience as IoT engineers, both on the embedded and the server side. We saw that our compatriots on the software end or on the server side had these like very detailed, like rich, like powerful tools for measuring the performance and reliability of their software systems. But us working on these little microcontrollers, a key like hardware component of the product we're delivering, did not have like these rich interfaces, these rich like diagnostic data that we could use to like evaluate our product after it like is launched and it's no longer on our desk for debug. So what you're looking at here is the DevOps lifecycle diagram. And you can see on the left-hand side, that's sort of like the pre-production phase of a product lifecycle. So when you're like coding, implementing stuff, designing the product, maybe testing it, like pre-production QA. And then on the right-hand side, we see things that happen post-launch. So this is sort of the operational side of the equation. And so things like, delivering over-the-air updates, operating the devices, whether that's like configuring or turning on feature flags, that sort of thing, observing like how they're performing, analyzing that data that's flowing back from these devices, and also debugging field issues. And so Memfault's strength is really, focused on that right-hand side. Although you can see there's a little bleed over into the test side, we do integrate on that side as well. Just gonna talk about the poll results real quick. So it looks like, a lot of folks have multiple properties of their devices that they're really concerned with. Things like, battery, power consumption is very sensitive to that, connectivity, performance, stability, 89%. That's like a really popular one. I think we all hold it in our hearts that stability of our devices is a key quality metric. So talking a little bit about how the Memfault SDK and backend solves or attempts to solve these problems. We have two components to our solution. One is the on-device SDK. And so that's a sort of a small library, source available on GitHub, so you can go and check it out. I'm talking specifically about the MCU solution that Memfault offers. We also have a Linux and Android solution that performs similarly, although obviously like different technology is in play there. So for the MCU side of things, we have this open source C library, 4.5 kilobytes of flash, 1.5 kilobytes of RAM, approximately in a default configuration. So it's designed to be like very, very small, can fit into like pretty constrained devices, but also provide like a lot of powerful data analysis, especially as like devices get more sophisticated, like more connectivity is on board. Maybe you have like multiple connectivity stacks. Maybe you have like, displays, other like rich features that you need to analyze. And especially as the software on device grows, there's more like memory contention issues, like CPU utilization, all these things need to be, profiled and evaluated. And it's especially critical to do it in fielded devices. And so, yeah, basically what you do is you take our Memfault SDK, install it into your fielded device. Install it into your device, and that does the data collection. So it hooks up to, the fault handlers on the device, catching things like asserts, stack overflows, various other sort of catastrophic events on device. And then it does the snapshotting of memory in order to like generate a core dump. All the data is collected like on the device, and it's up to the device's constraints how that data flows into Memfault. We designed the SDK to be like super lightweight and efficient in terms of like bandwidth utilization. So we have customers successfully using our SDK over, Wi-Fi, LTE, Bluetooth Low Energy, those like sort of higher bandwidth connectivity options, as well as things like LoRa, Zigbee, Amazon Sidewalk, like things that are a little more on the constrained side. They can also make great use of our solution. We actually have a customer that is deploying Memfault on buoys in the Pacific Ocean, where they have something like a 300 byte per day bandwidth limit. And we're able to effectively like provide information about device stability over that like tiny, tiny little budget. And so you can see, all the, sorry, you can see on the all the features that the Memfault SDK provides. That's all the data collection side of things. And then once the data like is gotten through that connectivity path and gotten into the Memfault cloud, that's where like all the sophisticated analysis occurs. So we're trying to offload as much as possible onto like the big, easily changed software side of things on the server side, so that the tiny little SDK on the device can remain like a reliable piece of code, does minimal data collection, barely any processing, just gets that raw data out so that we can then provide like analysis later. All right, next slide. You can get the next slide in. Sorry, are you still there?
Yeah, are we looking at the core dumps here?
I'm sorry, I am seeing the practically manage your device.
There you
slide. Go. Okay, awesome. Thanks, Tim. So talking about one of our like sort of key features at Memfault, we have this core dump feature, which is really, really powerful. What it does is the Memfault SDK will capture crashes on device. So whether it's like a hard fault, stack overflow in your RTOS, or some other like sort of failure, maybe an assert that you've inserted in your code to detect like a error condition. When that error hits, Memfault snapshots the memory that you selected, highly configurable. So you can, snapshot like tiny little core dumps of a few hundred bytes. They'll still provide like a nice stack trace and like a root cause analysis for the crash. Or you can expand it if you have like, ample bandwidth of memory on device. You can expand it to capture like the entire contents of RAM, and then you'll get like a super detailed view of what was happening on the device up to the crash. And this next feature that Memfault provides is sort of aggregating those crashes or error reports across a wide number of devices. So we automatically label crashes that are occurring. We like deduplicate crashes, so you can see if like a single error is occurring on like multiple devices, or maybe like you have a single problematic device that's just like crashing repeatedly. It can help you like decide which bugs are the most critical to fix, or which bugs like maybe you need to RMA a device to figure out what's going on in that particular instance. And the other component of our monitoring or diagnostic solution is performance metrics. So this feature is designed to super efficiently capture like statistical data on the device. So things like heap utilization, CPU utilization. Maybe you have like on-device temperature sensors or other like things you want to count. Like maybe you have like it's a door switch and you want to count like how many times it opens and closes. You can capture all that data on device. And we set it up to be really easy to use, similar to like how Golioth is designed to like sort of enable teams to operate independently to solve their own problems. Memfault's SDK is designed to enable a firmware engineer with just a couple lines of C code, add a new data point or change how the data point is recorded. And that gets automatically decoded by our backend. So there's no like sort of configuration or setup. There's no like cloud engineer that needs to get involved, that sort of thing. It's designed to be like really, really smooth and easy. So you can just start capturing the data that matters to you really, really quickly. we also have a few like built-in performance metrics that'll get you like going out of the box. So you'll get some insights right away without a whole lot of effort on your side. Oh, and we do have an upcoming webinar with one of our customers, Latch. They do like the keyless entry, like door lock systems at the end of this month. And they are going to provide like a lot of insight on how they've been using our performance metrics. They're one of our like more hardcore users. So they have some really cool metrics that they're capturing about how the devices are performing in the field.
Awesome. Thanks, Noah. So with all that out of the way, we're going to jump into our demo now. I just wanted to remind folks, you're welcome to drop questions in the Q&A at any point during the part we just went through or during the demonstration, and we'll dedicate time at the end to take a look at that. So I am going to briefly describe what this demo entails, and then we'll jump into actually doing it live. So first of all, just kind of getting an idea of the structure of what we're doing here. We're going to be using a RT1024 evaluation kit for our NXP device here. So I have it locally here on my desk. And on this device, there's firmware that's running the Memfault and Golioth SDKs. So they kind of sit beside each other there. And as Noah described, the Memfault SDK basically provides these little packets that we just hand off to the Golioth SDK and is getting sent, in this case, over Ethernet up to the Golioth platform in the cloud. But those can be sent over cellular or any of the other many transports that have been mentioned already. So we're going to show that off and use this as an opportunity to go through both the Golioth and Memfault platforms and talk through a little bit about what is happening there. So I'll stop sharing here for just a moment and switch over to sharing my screen so that y'all can see everything that's happening locally as well as in the cloud. So we'll get a brief view of our Zoom here, and then we should be able to jump over and see the serial port here. If that's not the case, feel free to let me know, or Kyle or Noah can jump in. But basically what I've done here is just restart the device, and you can see we get our nice banners here. And we're going to start up and connect to Golioth's cloud here. And that is going to allow us to start leveraging our device management features. And we'll use this as an opportunity to take a peek into what some of those device management features are. So starting with the Golioth console, I'm currently using a project in an organization. Kyle, Noah, and I set up this organization a while back when we were doing one of the NXP Tech Days event, and it allows us all to collaborate on a fleet of devices that we have here. And you can have multiple projects within an organization. We have this demo project here that we use for demos. And it's really nice because we can all come in and see the same thing. We can manage devices, do firmware rollouts, etc. So the first thing you'll notice is we have a number of devices. If we go to the device view, we can see some attributes about these devices, which are part of the Golioth platform. So first thing you're going to notice is that we have a blueprint, and this tells us about the type of device that this is. So as I mentioned before, this is an RT24 evaluation kit, and we've also informed that we're using Zephyr here. If we went and took a look at this, we could see all of this type of device that we have on the platform. You can also see here in the devices list, I've tagged one of these devices, the one that we're going to be using today, as a demo, which allows us to target it with specific things like settings and OTA rollouts and that sort of thing, if we want to do just a subset of our entire fleet. And so for this specific demo, we have a Memfault demo artifact, which is a firmware image, which we've uploaded. And we have the version here, which is going to match what we see in Memfault in just a bit. But basically, this has been deployed down and rolled out to just our demo device here. So once again, we've shrunk our fleet to target this rollout. And so we have this firmware running on our device. If we look into some of the device management features that are available, first of all, you're going to see a summary of some of all of the services here. So we'll see that firmware image that the device has reported is successfully running. You could also get a more detailed view or see the history of it here in the firmware tab. There's also some information about when this device was created. Like I said before, we previously created this organization and this demo device back for the NXP Tech Days event. So you can see when it was created, as well as connection status and how recently we've heard from it. Over on some of the other device management services that we saw on the slide earlier in this presentation, you can see our logs coming through here just fine. We're leveraging the Zephyr log backend to be able to send our logs over the network as well as over the serial port. So you'll see them here and in the cloud, and that's obviously configurable as well. We have settings that are enabling certain features that we're going to be using for this application. So in this case, we're enabling both metrics and core dumps, which is flowing through to configuration at runtime. Two of the other services we offer are our state and stream services. These are more free-form application services that allow you to send information to and from devices in the cloud. So here you'll see that we are reporting temperature data to give some information about the temperature of the device, as well as sending some stream data. In this case, some GPS information. And so you can leverage these services, especially early on in development, to be able to get a product up and running quickly. However, as we've harped on throughout this presentation, many of the times you want to actually send data to other destinations. And today that example is going to be sending data to Memfault, and we're going to leverage our remote procedure call service, or RPC service, to call a function on the device to actually trigger a core dump, which is something that we'd want to send up to Memfault. And so RPCs basically work by your firmware image registering a function with the cloud that you can then invoke from the Golioth cloud interface here, or via our REST API if you need to do this from your own backend or something like that. So we registered one called core dump, and it does exactly what you think. It triggers an assert and then restarts the device, and then we'll upload the core dump to Memfault. So I'm going to go ahead and call this method, and we should see that we get an OK response back here, and we see our fault occur. And then when it starts back up, it'll once again connect to Golioth and then send data to Memfault via Golioth. While we're having that come in and be processed by Memfault, I'm going to jump into the demo account that kind of simulates an entire fleet that Memfault offers, and let Noah walk through everything we're seeing here in the dashboards.
Awesome. Thanks, Dan. That was great. Yeah, so what we're looking at here is just sort of an example of what a Memfault dashboard might look like for like a fully populated fleet. Our little test account only has like a handful of devices in it. It's very concise amount of data. So to give you a better idea of what it would really look like in production, you can see here just a high level overview of what kind of data that Memfault is ingesting and analyzing. So number of devices that are reported in, the distribution of software versions across those devices. You can like drill down into various fields here if you want to find more detail about anything. And yep, exactly. Yeah, if you click through, we get to like a list of those devices that are impacted or that you want to find more information about. Maybe it has like some stranded devices on an old firmware version. You want to like find out why are they stuck over there. You can go and dig in really deep if you need to. And then we try and highlight and like make it really easy to identify the most popular, most like impactful issues that are hitting your devices. So you can see things like the number of errors that are being reported in like over time. So that breakdown, you can see like what issues are occurring like most frequently across the devices, and sort of like a little quick histogram. Like maybe you're looking for like some spike of an issue all of a sudden occurring, like maybe some daylight savings time bug or something happens and all your devices explode at the same time. That could be useful insight there. And then the Memfault SDK, something that does that's really nice is out of the box on many platforms. It'll capture reboot reasons and like decode the reboot reason registers. And what that gives you is this sort of quick insight into like what kinds of resets are occurring on your device. So whether that's like brownout due to a low power like issue, hard faults, asserts, crashes, watchdogs, or maybe intentional like user shutdowns of the devices. So it gives you a nice breakdown of what's going on sort of in terms of your device resets.
Awesome. And we can see the same overview here in our actual account that we're using, and obviously less devices. Do you want to kind of walk us through how we might go about troubleshooting this core dump that we just uploaded?
Yeah, so there's a couple of different ways of getting to the data that we're interested in, but we're going to follow the path if you're like investigating a single problematic device. So what we're going to do is we're going to go over to like the fleet view in Memfault and click on the devices list. And here there's only one active device, but there's a lot of like ways you can filter for devices of interest. Maybe you're looking for something that has a particular like property. So if it's, you know, battery life is below some threshold, or if it's running a particular software version, or if it's part of a, you know, a device cohort, like a device fleet subgroup, that sort of thing. You can also apply nicknames, that sort of thing. But if we click through into this specific device, the one that's on Dan's desk, and we scroll down, we can see a lot of information about the device in sort of a highly detailed view. So this is like looking at the microscopic level, like a single device that we're trying to diagnose. And we can see there's like a number of device metrics that are being reported in. So things like, you know, how much data is being sent, how many like, you know, UDP errors are, you know, being generated on device, how long the device has been connected to Golioth. Like ideally, we want these Golioth-enabled devices to be like 24/7 connected if that's the expectation, like they're a wall-powered device. So giving us information about like, okay, is it losing connectivity when it, you know, should be connected? And then things about like memory, like heap usage. But if we look in that traces swim lane, we can see there was this assert that was generated. And so if we click through into that, so this is the core dump view. And so we had sort of skimmed through it during the presentation, but what we're seeing here is a crash that occurred during this like handle core dump timer function in the code. And that's the RPC handler that Dan invoked and crashed the device. And so it's pointing you right to the line of code. Like you can see main.c line 60 is where that thing's implemented on our test app. But yeah, it's directing you right to the line of code where the failure occurred. And you can see the issue title is even, you know, it's including the function. So handle core dump timer is the function that was running when the device crashed. So it gives you like a really quick insight into like where this device crashed. And you can also see we've got 22 recent traces of this. You know, as we were testing this before the webinar, we triggered the core dump a few times. And so all those instances of this crash got grouped under the same issue. And so you can click back through. So if you wanted to see like the same crash on like a different device, or you want to see like another instance of the crash, you can do that. And it can be helpful to gather like a little more data if like some devices are experiencing a similar but not identical crash. Memfault has like a deduplication algorithm that tries to group things up that way. The other thing I'll point out is we have this logs tab. So similar to how Golioth is like ingesting logs from the Zephyr backend, Memfault also instruments those logs. And if a crash occurs, we scoop them up. Yeah, so Golioth has that really nice log view. So as the device is operating normally, you get a great view into like on-device logs, super highly configurable and whatnot. In the case of a crash, Memfault scoops up the most recent logs on the device and includes that in the crash report. And then we decode it on our backend. So you can see if there was like some sort of issue like prior to the crash that maybe like provides insight, like maybe like Wi-Fi went down or some temperature sensor like out of range reading occurred, and you happen to have a log like associated with that. It can be pretty helpful, especially on complex platforms like Zephyr with like a million subsystems all like interacting with each other. Having all those logs like as part of the context for the crash can be super, super valuable.
Awesome. Is there any other awesome, cool, that sounds great. Well, I'm going to go ahead and stop sharing here. First order of business, I think that we came right in on time, on the minute, so nicely done, folks. And it looks like we also have some Q&A here that we can start going through as well. Mariah, if there are any questions that you want to drop in, feel free to jump in with those as well, but I'll pop these open and go through a couple of them. So the first one I see here is where does Golioth and Memfault SDK sit in microcontroller? I mean, first there would be BSP, then how, then is it Golioth or Memfault? I'll let you start off, Noah, and if there's anything to add from the Golioth side, I can jump in on that as well.
Yeah, this is a great question because yeah, when we think about like building a microcontroller based application, it's nice to think of these like layers, like, okay, what's, you know, driver layer, what's the application code, like where do things sit? Where Golioth and Memfault SDKs sit is sort of in the middleware layer. So somewhat in the way you would think of like a USB like protocol stack or something like that. So neither SDK necessarily has a tight coupling to the hardware. You know, these are software libraries that sit on top of your existing application. And the Memfault SDK probably reaches a little deeper into the application in the sense that we do instrument like the fault management or fault handling system of various types of microcontrollers. But otherwise, things are typically invoked like on demand. So like when you want to collect metrics or when you're ready to export data off device, that's sort of up to the application's needs.
Yeah, I think that was a great outline there. One other thing I'll mention is with both the Goliath and Memfault SDKs for the various platforms we integrate with. So in this case, we're using Zephyr. No, I think you mentioned ESP there's quite a few out there. We both really strive to package in the format that the platform wants. So for example, providing a Zephyr module or something like that that makes it really easy to integrate, just as you would, some of those subsystems or other modules that may be offered.
Just to touch on that as well, one of the questions that came in before the call was on the delivery of the software, and like Dan mentioned, we're working with Memfault with the Open Synthesis Pack delivery mechanism. I'll share it because I prepared it from that question, but that's another way where more and more customers are saying, how do I get your SDK into an NXP project? And so we're working with Goliath and Memfault to deliver it that way, as well as, like you said, the Zephyr project and GitHub examples, things like that.
Awesome. Another question here. Could you explain how does the manual request for the core dump work? There's a callback that will be executed in the MCU to trigger the Memfault's data transmission. Yep, that's pretty much right. So this is obviously for a demo case here. RPCs can invoke any behavior you want on the device. In this case, we were just triggering an assert. So back in the Memfault console, you could actually see that it was a software triggered assert that calls the core dump. And so we're triggering that assert and then rebooting. And then when we come back up, the Memfault SDK has that data ready for us to upload via Goliath to the cloud. Noah, was there anything I left out there that you'd like to add?
No, perfect. The only thing I wanted to pile on there was Memfault. If you're using a platform like Zephyr, ESP IDF, or even bare metal, we have like a test console that is optional part of the Memfault SDK, and so that like exposes a bunch of test commands. If you want to like interactively like trigger a hard fault or like an assert or some other crash, you can do that to like stimulate or like simulate those types of device behaviors and like see what happens like when Memfault decodes that data.
And then when we did this before, there's a really good interrupt blog talking about setting that up, the assert and the when you do trigger it efficiently, sharing data, how do you package that data? So that's once you learn how to initiate the manual request, it's important that they read that blog because there's some lessons learned, right, Noah, where you don't ship everything. You learn to be smart with the data that you're transmitting across the packets.
Yeah, exactly. Yeah, you don't want your diagnostic data to be like 90% of your link budget, and that's where like Goliath really excels at like very compact and efficient like transport for both application and diagnostic data.
Awesome. Another question I see here is, does Goliath or Memfault make OTA possible, or do they expect an OTA mechanism to be present on the device and then call it throughout the registered fleet? So we did see in the demonstration the Goliath OTA features. Memfault also offers OTA. So those are services you could get from either one. It's a similar model there with data flowing through Goliath to Memfault. So you could have upstream OTA as well. So both offer the service as part of in the Goliath case, kind of focused on device management, and in the Memfault case, focus on correcting those things that you're observing via your debug and that sort of thing. So anything else to add there, Noah or Kyle, if you had any mentions about OTA on y'all's side?
Yep, you nailed it. Yeah, both Goliath and Memfault, like Dan mentioned, both have an OTA offering, and both are designed to be similarly like easy to use and super compatible with like whatever existing like OTA mechanism you might have. So we're not saying like, oh, you have to install our specific bootloader, like our update agent or whatnot. Yeah, it's sort of bring what you have, or we have examples as well, both in Goliath and Memfault side.
Awesome. Question around minimum memory requirements to add Goliath and Memfault SDK. No, I know you mentioned it was 4.5K ROM, 1.5K RAM. Is that right for Memfault?
Yep. Yeah, that's right.
Awesome. For Goliath, I don't have exact minimum memory requirements. I will say that we do optimize to be lean and work on constrained devices. Given the kind of like breadth of functionality we offer on the platform, it does vary quite a bit depending on all of the services that you're using, and if you're using observations and things like that, which are what allow us to do things like a remote procedure call. So really allow you to kind of pick and choose what's best for your use case there.
That's a
All
great
right.
point, Dan. Like we've definitely found that that's super important. Like the configurability of the SDK, like making sure there's no one size fits all. Like these, cow ear tags versus like a smartwatch have different requirements. So
Yeah, that's a really good point. That's one of the things that actually come up. I haven't seen a specific question about this yet, but I mentioned that we use CoAP and DTLS as our protocol, and we have a series of blog posts talking about the decision to do that. And frequently the question comes up, is this protocol more efficient than, is X protocol more efficient than Y protocol? And the answer is always it depends, right? If you have a really stable network connection, then using a reliable transport may be more efficient than using an unreliable one, right? If you have a really spotty cellular connection or something like that, and you're okay with dropping some data, then you're going to have a lot of issues with doing reliability at the lower layers of the stack, because you're just going to have tons of retransmissions and things like that. So with all of these things, right, being adaptable and being able to support a lot of different use cases is super important. So that's a great point. Does Memfault provide any tools to help debug issues like deadlocks between threads that might lock up the device connection to the cloud, but the device hasn't hard crashed and is just running in a stuck state?
this is a great question. Thanks, thanks for asking it. We're actually prototyping some automatic deadlock detection stuff. We do support it on some platforms already, more on the niche side though, so nothing like the NXP chips or anything like that. But in general, yeah, Memfault provides Task Watchdog implementation if your platform doesn't already have it. And Task Watchdog is unlike a traditional watchdog, which is essentially just looking for like a busy like while loop just sitting in one spot in your code. Task Watchdog is looking for a thread that doesn't like advance, so it's not doing the job that it should. It's stuck at some point. And our expectation is generally, although of course it's specific to the system, like all tasks should be either sitting idle or doing the work they're supposed to be doing, but there should be no task that's like stuck halfway through its operation cycle. And so task watchdog systems, there's subsystems in the ESB IDF and Zephyr that do this, among other like platforms. But Memfault does have like a sort of minimal implementation if you don't happen to have one already. So what that does is you register tasks for like this task watchdog feature, and then you have to like pet the watchdog periodically, same as a normal watchdog, but it's task specific. And then if you happen to like end up in this scenario with like a stuck task or like two tasks are deadlocked on each other, and one of them happens, you've enabled that task watchdog feature, you'll get a crash. It's similar to an assert where it's like an intentional crash. You're trying to detect this scenario on the system. And then Memfault, you'll get that diagnostic report that cored up from Memfault that'll show that this issue was a task watchdog fired. It was this task that was involved, and that sort of thing.
Awesome. There's two questions here that I think we can bundle together, and I'll hand this one off to y'all. Is Memfault tied to NXP hardware, and is Memfault tied to Zephyr RTOS or support a bunch of other RTOS?
But yeah, great question. We do love the
no, I think we should tell them that they can only use Memfault and Goliath with NXP.
That's right.
That would be untrue. No, I actually learned about Memfault when I was working with Silicon Labs products. It works with. I mean, you guys are represented with all the semiconductor manufacturers, right? I'm sure you.
Yeah, we do. We love the NXP parts; they're awesome. So for sure. But yeah, a lot of pretty much any Cortex M, so like the ARM chips, we're going to support. Some of the other stuff, like the 8-bit picks, those sorts of things, you're going to get a reduced like feature set. But we try and be like pretty compatible across like a wide flavor of the popular embedded devices. And we do have, I did mention it briefly, but we do have like Android and Linux offerings as well. If you happen to be like sort of on the, we've talked a lot about MCU here because that's sort of where we live and breathe. But if you happen to be like way off in Android and Linux, Memfault also does support those platforms.
Absolutely. Yeah, and also just kind of implied by that answer, definitely not only Zephyr on either the NOAA or on the Memfault or Goliath side. but I will say that with regards to hardware support, just kind of a shout out to Zephyr, because I know we're all big fans of it as a project. It does enable us to really easily support a lot of different hardware, which is really great. So integrating with Zephyr definitely opens up the door to a lot of hardware. That being said, right, we do integrate with all platforms and want all hardware to be available to our customers.
Yeah, the demonstration that we did 2 years ago, Noah, was with free RTOS. So we have examples with free RTOS, and now with this example with Goliath, we have a Zephyr. And then with the Zephyr, NXP is investing a bunch in Zephyr. We see the benefit within the NXP ecosystem. I mean, it allows, like you said, the ability to evaluate different semiconductor manufacturers. It allows NXP customers to more freely evaluate an LPC versus an RT or even an IMX, or our automotive products also have some contribution to Zephyr. So we see Zephyr as a company, as a strategic benefit, not only to ourselves, but to customers. It's grown in popularity.
Yeah, absolutely. I feel like perhaps the greatest indication of how easy it is to get going with it is putting together this demo, the firmware image that we built. Noah and Sam, our firmware lead here at Goliath, put together the firmware for it, and it was minimal to be able to add support and get this demo running. So really great. Also, we had a couple different boards, I think, evaluation kits from NXP spread between us, and we were able to run it, across all of them.
So let's
Super
talk. Let's
quickly.
talk about that. Why don't we? I
Yeah.
mean, we'll stick around, right? We said we would stay as long as questions are coming, but I think some people may have something at the top of the hour. Why don't you, Dan, and Noah talk about how should they engage with really Goliath and Memfault about this platform and this example? How do they get started? How do they evaluate it?
Yeah, so the first thing I'd say is we do have a sign up for getting a preview of this functionality. And so that should be linked in our blog post from earlier this week. I'm sure someone can also drop it in the chat while I'm talking here. But that's the best way to get notified when you can use this directly. And it will be natively supported, so it should be pretty easy to get started. We'll also be coming with more documentation around how that works, both on the Memfault and Goliath side. In the meantime, our existing SDKs and examples can help you get up and running with the NXP devices really quickly. So I know, for example, I was using the 1024 here. We have an example of running that in our firmware SDK today. But that's kind of the roadmap for what's coming here. So definitely make sure to get your name on that list. Those will be the folks who get access to what we're showing off here earliest. Anything to add from Memfault or NXP sides there?
Yeah, that's it. I mean, you can check out Memfault's docs pages as well. We have guides for, we have a specific guide for the NXP RT series project. So it'll get you up and running really fast with Memfault. If you want to, install it on some other device, that's totally fine. There's plenty of different guides on there that'll sort of walk you through what's involved in getting that loaded on your device and data collecting.
Awesome. Let's see. I think we got all the Q&A from the audience. There might have been a few that were submitted before that I'm going to pull up real quickly here since we have a couple minutes left.
Why don't while you're pulling that up, I'll
Yeah,
answer that question I said I did some prep for.
go
So
for it.
as I said, the question that came in was, and it came up in this Q&A as well, is how do you integrate Memfault and Goliath into the NXP projects? What we've been working on that I'll share is how we can integrate it using Simsys packs. Noah and I worked 2 years ago on the integration with our SDK as it is today. He has the getting started guide, which anybody could get through within 30 minutes and have it up and running on an NXP project. But we're working on even more ways to simplify and align our companies. So I'll share real quickly here my screen. I have our VS Code extension. Hopefully I'm sharing the right screen here. So what we have is our VS Code extension over here from NXP. We have Simsys support. And Simsys is a standard way of delivering software, whether you're using IR Workbench, you're using ARM MDK, or you're using the NXP tools, either Eclipse or VS Code. You can get the software from NXP, you can get the software from many partners using this standard format. Think of it as like an archive zip file on steroids. So what I wanted to just show is with this new UI, with whichever of those IDEs you prefer, you can go now and you can say, you know, I just saw this webinar from Memfault, and I want to add it to my project, this GPIO LED output. And so you can go in and you can get that core software from Memfault, and those will add all of the support files that are included through some script files that Noah does normally. So it just takes out that extra step. It allows the customer to put this in, and then it will add it to your existing projects. There's a very similar UI to this in, as I said, Workbench and IIR projects, or in our Eclipse tools, or in MDK tools. So it's just something that you'll see more in the coming months. But you can see if we just put like Wolf SSL, their members contributing. Sager's RTOS is also, so it's a real easy way for customers to start adding these components into their designs. So that's something we're working on with everybody. So
Awesome. I think we're getting pretty close here. A couple questions that maybe we can just go through quickly here. What chipsets are / will be supported by NXP with Zephyr? I know you can check the NXP hardware catalog to see the ones that are currently available. Anything to add on that, Kyle?
yeah, so as I mentioned, NXP is increasing our investment and increasing our time with the Zephyr project. So now with all of our product launches, you should expect to see Zephyr support for those products. So we will launch those products that I mentioned in the slide, the MCX, exciting new low-end MCU, as well as that RT1180. Those will be launching in January, and you will see support within the Zephyr project. And that will continue with any project or product that we launch at NXP. Over time, the contributions for the support will be contributed as all Zephyr products are. And that's where you get that benefit of the community in Zephyr. So people like Memfault and Golioth will start to say, hey, I'm going to add some specific support for those evaluation kits or projects. But you can expect from NXP that if we launch a new product, you will see some support within the Zephyr project. So
Awesome. That's great to hear. There's a quick question on what protocol is being used. I think we mentioned that earlier, CoAP and DTLS over UDP in this demo case. There's also a question about using Memfault with Bluetooth, which I know is certainly supported. Anything to mention on that front, Noah?
Yeah, I would definitely support a ton of customers on that today. We have a few like sort of libraries and utilities to help you like get up and running. We also have defined our own Memfault diagnostic service, like BLE profile. That's supposed to make it like simple to like shuttle that Memfault data over to whatever gateway, like mobile phone or whatnot, and get it over to Memfault. Yep, yeah, it's well supported.
Awesome. Yeah, and on the Goliath front, if you are using Bluetooth, you can certainly, from whatever gateway you're talking to, go through Goliath with that as well. So this is certainly not constrained to just on the constrained device. Let's see. I think we're at the top of the hour here. Are there any more questions from the audience? It looks like we've answered all of them. If there's no more, I think we can probably start trending towards wrapping it up here. Noah, Kyle, great to work with y'all on this. I'm super excited for the folks who are going to be notified on the wait list soon about being able to use this in products. I think this is going to be super beneficial for our customers of all three of our companies. So any closing thoughts from either one of y'all before we go ahead and wrap it up here?
I'll say Oh, see, we waited. Collision avoidance. So I would there are a lot of topics that we probably didn't address. So if you came to the webinar and you were interested, but we didn't address a topic that you wanted to cover, send it in the follow-up email, and we will follow up with you guys.
Awesome. And I have just shared the resources slide here. Apologies for not pulling that up sooner. But as you can see here, there's a link to the waitlist, as well as information that's been shared in the chat about Memfault, Golioth, and NXP documentation, especially how they work together, and some information on licensing and commercial support as well.